All right, this is the Algebra 2 Unit 7 Lesson 2 video. So we've been introduced to rational functions, and this lesson 2 is going to be all about the graphs of those types of functions, and they're going to be focusing on two main types. And so the first type of rational equation they're going to have us graph are going to be what you see here. And so there's kind of one big concept that we need to understand when we're dealing with these. And it's this, that when we look at this equation and we're saying y equals, I should probably put that in the same color, shouldn't I? It's not necessarily as simple as just typing that into the calculator and seeing what we get. Because what we have to kind of understand is that if I were to simplify this rational equation and factor the top of this, I would get the following. We know that 10 has factors of either 10 and 1, 5 and 2. And if I want to make -3 out of those, I'm going to use 5 and 2. So I'm going to have x and x, 5 and 2. Again, I'm just doing basic, what we call trinomial factoring. And it's going to be -5 and +2 because -5 plus 2 makes -3. So this is what I would get here in purple if I simplified. And then to take that one more step, the x plus 2's would cancel each other out. Now, that doesn't mean that the graph of the function is just x minus 5. Because the fact that we had this x plus 2 on the top and the bottom of the fraction does have an impact for the graph. So let's jump over to the graphing. And I'm going to try to type that entire fraction in here. So we had x minus 5, x plus 2 over x plus 2. So I will say, just for the sake of argument, the graph does look very similar to, x minus 5, there we go, to the purple graph. So look, the purple graph and the red graph have basically the same shape. The problem is, and that's something you can't see on this graph, is the actual difference between these two graphs is that if I were to zoom in very, very, very closely on the value at -2, you can't see it, but what we know is that, and there it is if you see it flash by, and I'll just kind of hit that right there. You see how there's an open circle on my cursor right there at -2. And that's because this graph doesn't actually have a value at -2. Now you can't see that just by looking at the graph. But again, like if I zoom in enough to where it's easy for me to mark that, you can see right there, -2 is undefined. So it goes right up to it, but at -2 it's undefined. Whereas on the red graph, there's no problem. It goes straight to 2 and it hits 2 and it goes -2, -7. So what does that mean? Well, what it means is that the graphs of these rational functions have to take into account this thing that's in the denominator. That thing in the denominator tells me that there is some issue at -2 on the graph. So why is that? Well, we know from our math careers, hopefully, that you can't divide by 0. And so because we can't divide by 0, the graph will not allow that to happen. The values will not be there, which is why you see, again, at -2, you've got an issue with that value. There is no value at -2. It's undefined. So what I'm telling you is this. The graph of rational functions in this form look like the graph of whatever you get when you simplify it. So the graph looks like x minus 5, y equals x minus 5, except x does not equal negative 2. In other words, you can have all of the values of x minus 5 except at negative 2. And so this is kind of how you would write that mathematically. But what you need to understand is that on the graph, it looks like a hole in the graph at that point. So let's jump over to our lesson and see what this actually looks like. We're going to be jumping back and forth a little bit. Here we go. Which is the correct graph for x squared minus 4 over x minus 2? And then they've even shown you the way to simplify it. We factored it, we canceled out our x minus 2's, and the resulting graph is x plus 2. So what that should tell you is that, yes, the graph is going to look like x plus 2 graph. Except, and you'll notice all of these graphs look that way. X plus 2, x plus 2, x plus 2. They all have the same basic shape. But the difference between them is, where is this gap? Well, this last option doesn't have a gap. This option has a gap at negative 2. This option has a gap at 0. And this option has a gap at 2. Where should this gap be? In order to know where the gap is located, you need to look at the denominator of the original fraction. So when I look at that denominator, and I say, okay, x minus 2, and I set it equal to 0, and I solve, the number I get is the thing it cannot equal. So in a sense, it cannot equal 2. And so that is why that is where the gap is located, which is why we should be selecting this first answer choice here, where the gap is at 2. All right, let's see if there's another one like that. Yes, there is. Which is the correct equation for the graph? Okay, I can see there's a graph. It crosses at negative 2 on the y. It has a gap at 3, which tells me that my denominator needs to not be able to equal 3. So they actually make this pretty easy on us. Sorry about that. Because you really only have one option that makes any sense. We know that this graph is going to look something like this, because we know that the issue is that there's a denominator here that limits the fact that at 3 there cannot be a value. Again, so that is why we want to choose that option. So again, big idea here, rational equations that have a denominator have a gap in that spot when that term is eliminated. So because we canceled out these x minus 3's, that's why we have a gap. Because later we're going to learn about asymptotes. Asymptotes are another way that this can look. But when that term, when that thing is crossed out like we have here and here in green, because these are crossed out, that is where the gap is located. There was a negative 2 limitation on this graph, which is why x cannot equal negative 2. So let's keep going. So now we get into the second type of graph and second kind of concept that they want us to know, and that is how to take the basic, what we call the parent function of 1 over x. Let me graph that on here. And ask the question, what happens when the graph of 1 over x is changed in certain ways? What you see here in blue would be what we call the parent function of the reciprocal function. So the reciprocal function is the function 1 over x. So y equals 1 over x is called the reciprocal function. So reciprocal function 1 over x. So the question becomes, what about transforming this graph? What can I do to change this graph in certain ways? So one way we could change this graph is we could just add or subtract a number off of the end of that graph. So what if we did that? That is what we call a vertical shift. So when we add or subtract, and adding is going to be the means that the graph moves up. Subtracting is going to mean that the graph moves down. Let me change the color of that so it's a little more clear what's happening. So again, this is a downward shift. Oh, wow, that's wrong. This is an upward shift, Mr. Matthews. And this is a downward shift right there. So let's look at what that looks like actually on the graph. So here's the parent function. Let's do 1 over x plus 2. So it's kind of maybe hard to see, but this before the center of this graph was kind of right here at the origin, and now the center of the green graph is in a sense right here at plus 2. So this graph has moved up 2 units to there. Okay, so you can almost think of it as like a crosshairs. There's kind of a center point of this graph, the blue graph that's like right here. And the center point of the green graph is now kind of right here. And so it's been moved up 2 units. So that's what we're talking about when we say a up shift. So, and if I went ahead and go over here and change this to -3, oops, the green graph has now been moved down 3 units. Again, looking at this place on the graph where there's kind of this crosshairs idea where the center of that graph and what's happening on that graph is now, sorry, yeah, there we go. Trying to get that 3 to show up for me. There we go. That center is now here as opposed to here when it was the blue graph. Right there was the center of that graph. Now the center of the graph is located. Oh man, sorry guys. Clear that out. Zoom out again. So what I'm trying to say is the graph center has moved from here, 1, 2, 3, to here. And so you can see that green line, the center of that graph is kind of located there now. So that's what happens when there is a change to adding or subtracting off the end of that graph. Hop back over here. I do not like that at all. There we go. All right. So that's what's happening with vertical changes in the graph. Sorry, guys, I'm fading a little bit. What happens when I do the following? What happens when let's say I change the graph in this way? Y equals 1 over x minus 2 versus y equals 1 over x plus 5. Well, when I subtract a number here, the graph is going to end up moving to the right. And when I add, the graph is going to end up moving to the left. So this is what we call a horizontal shift. I won't get too far into it, but looking at my graph over here, again, if I go down here and make this -2, the graph is shifted over from here as the center being now here. The center of that green graph is now located at 2. Or if I were to add, zoom out a little bit, the graph has gone from having a center right here to having a center over at 5, or at -5 rather, right here. 1, 2, 3, 4, 5 over. And I can combine these. What if I did a +5 and a -3 on the end? So now the graph has been moved where the center is now -5 and -3. It's down there. So you can combine the different types of shifts. The last type of shift we want to discuss is what happens when I change the number on top of that fraction. So what if I change the number there to y equals 3 over x? Well, when I do this, it's what we call an enlargement or a dilation. And let's look at what that looks like. Let's hop over here and say, okay, what happens if I change this to a 3? Okay, so take a look. The blue graph is our original graph, and the green graph has kind of been pushed out, kind of stretched out from the center of the graph. So when we change this number, the more I change it, the more the stretching is going to occur. Look at if I go from 2 to 3 to 4 to 5 to 6 to 7 to 8 and keep going, the graph is being stretched out more and more and more. So that number is being enlarged or dilated by that amount. Stretched or enlarged is the terminology they use. So I've just summarized everything in this green box right here. These are the effects of parameter changes is what they call it. So taking a look at the lesson information or the questions, which is the correct equation for the graph? I can see that we know the original graph has a center at 0, 0, and the center of this graph is now at is up 3. So the graph has been shifted up 3. So you have to decide, how do I get a graph to shift up 3? Well, vertical shifts are here. You have to add a number onto the end. So I should be looking somewhere where there's a adding of 3. So where do I see that? Well, I see this one is a dilation. That's not it. This one is 3 minus that. That's not it. This one has a 3 being subtracted from the bottom. That's not it. And here we are. Our answer is being added 3 onto the end. And that's what you need to do in all these problems. What's the correct graph for 1 over x plus 2? Well, what happens when I add a number to the bottom? Well, we said when we add a number to the bottom, it shifts to the left. There's an example of that right there. Plus 5 means to shift to the left 5 units. So we're looking for one where the graph has been shifted 2 units to the left. I'll let you do that one on your own. And then they ask us some questions just verbally. Describe how this graph, 4 over x, will be different from 1 over x. Well, I described it over here for you. It's an enlargement or a dilation. You need to find the one that matches that. Again, number 6, plus 5. Number 7, plus 3 on the bottom. So you just need to decide what has been changed about these different graphs based on the new equation. So use the notes to your advantage on that. Then it introduces this conversation about restrictions. Restrictions on a domain. So when we say restrictions, you also hear them called restricted values. So restricted values. A restricted value in terms of rational equations is basically saying this. If I have this rational equation, 1 over x, what numbers can x not equal? We kind of already discussed this above, but basically you need to set the denominator equal to 0. What makes the denominator 0? So in this one, it would be that, there's a different color there. For this one, we would say, well, x cannot equal 0, because if x equals 0, then the denominator is 0. Or if I had something like this, x plus 3 over x minus 4, what would be the restricted value? Well, I know that x minus 4 cannot equal 0. So x cannot equal 4, because if x equals 4, it will make the denominator 0. So what it's telling you need to do is you need to just look at each of these problems and say, what can I not put in there? What will make that denominator equal to 0? So you say x cannot equal that number. So I already gave you the answer on the notes page to number 8. I also showed you how to do number 9. What can x not equal? It does not matter if they have been marked out. So the fact that 4 and x plus 4 and x minus 5 have been marked out doesn't matter. X can still not equal any of those numbers. It cannot equal whatever makes x plus 1 equal 0. So I'll basically show you x plus 1 cannot equal 0, x plus 4 cannot equal 0, x minus 5 cannot equal 0, and x plus 6 cannot equal 0. So you're going to have 4 answers. You need to solve each one of these equations and tell me what can x not equal for each one of those. In other words, what makes that little term 0, x plus 1? What makes x plus 1 0? Negative 1. What makes x plus 4 0? And then you just need to go through like that. Number 10, you need to factor this yourself. So you have to take this and you have to come up with a factored form. I'll just kind of get you started. Your answer is going to look basically like that, with numbers to factor x squared plus 6x plus 9 and numbers to factor x squared plus 7x plus 12. Hopefully you remember how to do some of that basic factoring stuff, because they're kind of expecting you to know how to do that by the second half of Algebra 2. It's something you learn in Algebra 1. So you need to factor that. What are the things that multiply to make 9, but that add to make 6? What are the things that multiply to make 12, but add to make 7? So you need to factor, and then once you factor, you look at the denominator and you say, what things cannot equal 0? Number 11, find the determinant of the coefficient matrix of a linear system. I will post a video. These are review questions, so I will post a separate video going over these review questions. There's just 2 of them, and I'll post that separately. All right, this is just a quick video to go over the 2 review questions on Algebra 2, Unit 7, Lesson 2. First one asks about the determinant of the coefficient matrix. When it says the coefficient matrix, it's referring to just these values here. So if I wrote a coefficient matrix for that, it would look like this: 3, -2, 2, and 5. And then this idea of a determinant, may or may not remember that from when you learned how to do matrices, but basically I take the downward diagonal values and I multiply them. So I'll do 3 times 5, and I subtract the upward diagonal values times each other, 2 times -2. So that minus that. So 3 times 5 is 15, minus 2 times -2 is -4. 15 minus -4 equals 19. And so that's where we're getting that answer from. Again, these are reviews, so you may not remember these from working in those lessons back in the first half, but that's okay. Next one, find the solution to the system of equations. You just need to graph these 2. Graph them and find the place where they intersect. So I'm not going to say much more about that, but you can just use Desmos to graph the 2 equations together. Put the first one in one graph, the second one in another graph, and again, find the place where they intersect. Just a heads up, one of these is a straight line, and one of them is a quadratic function. So you're looking for like a place like that on the graph where they intersect. So just be aware of that before you start that one. And that's it for the review, or the review questions.